welcome everyone. It's great to see a lot of people here. If you have used ChatGPT, you may already have a sense of how AI has now, more than ever, a profound impact in our lives. And it's natural to wonder, for example, how education will change now that our kids can essentially ask large language models they can, to type their essays. But ChatGPT is really only the tip of the iceberg. You may not know, but there are many changes underway in healthcare and the way people work. So as I speak tonight, AI has been used across the board for example, guiding school admissions, guiding hiring in companies, and many other high-stake decisions, including even drug discovery. So considering the role that these AI models have been playing in our lives, if you're curious about how they work and trying to get a better understanding of AI, you're not alone, right? So if you're a tech enthusiast or just a concerned citizen, you came to the right place. I'm going to do my best to explain in lay terms what is AI and how we got to the point where we are. So I'm Fabricio Murai. I'm an assistant professor at Worcester Polytechnic Institute, WPI. And I have joint appointments in the computer science department, the data science program, and the recently launched AI program. Okay, so a lot of people ask, a lot of people are concerned about the new developments in AI, and they're even scared. So if you ask them, well, what does the future of AI hold for us, then some of them might think of like the Terminator movie, and at some point the AI will surpass human intelligence and enslave us, and then we're doomed. But some other people have a way more optimistic view, and they would say, well, AI will progress in large strides and enable unforeseen benefits to humanity, like prolonging life, and we're going to cure all diseases. Maybe too optimistic, but this could be a really interesting and long discussion whether like, we're going to go in one or the other direction. But rather than speculating over what's going to happen, my goal here is to explain what AI is and how we came to this point. Okay? So raise your hand if you have tried ChatGPT before. Okay, I see about maybe 10-ish people. So if you haven't, I really recommend you try. And I'm going to show you, maybe I can show you like some examples of prompts that I have tried. I use it very often to, I guess, fix some grammar mistakes, making like the sentences look better. Because I'm not a native speaker, I'm from Brazil. And, but there's a bunch of different uses. Like if you can try kind of trying to prove theorems, you can try, essentially, maybe I can show you one of the examples when I was preparing this talk, and then I was asking maybe questions that you can find on Wikipedia. When was Marlborough established? And then like, you get an answer. And then I just use this prompt to do something that I was going to use later in the talk. So essentially, you can type, and it's like a chat. It's like a discussion, and you can ask for improvements in the previous answers. So kind of just to give more examples of how we can use. You can use for getting recommendations. You can tell like the kinds of movies or songs that you like. And okay, I want to listen to something different today, but that I still like. If you have a bunch of stuff in your fridge, and okay, I don't know what to do with that, but it's going to go bad very soon, then you can ask for like chef recipes and making something very, very sophisticated, or something very simple if you. If you're like me and cannot co-create something sophisticated. Obviously, like jokes, and a lot of people use to learn new things. When you're starting to learn something, you can ask questions. You can, if you have doubts, you can try to solve them. Even though there's no guarantee. If you look here, and I'm going to try to show at this very bottom, it says ChatGPT can make mistakes. Consider checking important information. That's a good disclaimer. They didn't have that before. So, okay. Coding, when if you're into programming, or if you're learning how to program, you can get like a kickstart just by saying, okay, I want to write a code that does something, and then it gives you kind of a beginning code, and you can build on that. People have used it to improve social skills, and you can ask for tips, language translation, and I've used that for trip itineraries. I went to Newport last year, and I wanted to create a schedule of all the things that I should see in Newport, and it turned out to be almost perfect, except they listed an ice cream place that didn't exist. Right? So one of, I think, the coolest uses I've seen on my Twitter or X feed is this guy who took a picture of this bunch of parking signs, and I get completely befuddled when I see things like that. And it says, and he wrote, "It's Wednesday at 4 p.m. Can I park at this spot right now? Tell me in one line." Yes, you can park for 1 hour starting at 4 p.m. So maybe one of the best uses. So other, I guess, other tool that became really popular is called Stable Diffusion. And I also recommend you to try. You can essentially write a description of an image that you want to create. For example, in this case, I wrote, I just borrowed this from someplace in the internet. Serene lakeside at sunset, reflecting the vibrant colors of the sky, devoid of any human presence. And then generated this image. This image didn't exist before. It's not like you found on the internet this image. This is an image created from my description. If I change the description, it's going to generate a new image. So you can imagine like all the uses this can have if you're like a graphic designer, for example. Okay, so now that I give you examples of applications, let's talk about what is AI exactly. So it turns out that AI ideas regarding AI have been floating around since the 50s. In 1950 specifically, Alan Turing, which was this English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist, wrote this paper where he coined the term machine intelligence. And in this scientific paper, he was trying to define intelligence. What exactly is intelligence, and how can we tell if a machine has achieved intelligence? So he proposed something called the Turing test, where a human, C here, is behind a wall, and the human communicates with either a computer or another human through a teleprompt. So essentially, they type something on the keyboard, and then they get a response. Okay, but they don't see if they got a response from the computer or from the human. And the whole point of the test is, can the human distinguish between the machine or the human during a written conversation? So this is what he proposed, and the idea and the answer is, well, if a human cannot distinguish between them reliably, then the computer has achieved human intelligence. Okay. So he is very famous, as I said. He's considered the father of both artificial intelligence and theoretical computer science, and has inspired a movie called The Imitation Game. Have you seen this movie? Yes. So that's Alan Turing. That's inspired on Alan Turing. I think it's a brilliant performance from Benedict Cumberbatch. The movie has received 8 Academy Awards, or nominations, if I'm not mistaken. Highly recommend it. Okay, so after he came up with this idea, then in 1956, a bunch of researchers, they organized this Dartmouth, a workshop at Dartmouth, not too far away from here. And yeah, so some of the people shown here in this picture are considered the godfathers of AI. So what did they do exactly during these several weeks at Dartmouth? They were trying to discuss and answer the question of can machines be capable of simulating human intelligence? Right. First, Alan Turing proposed a test, and then they were trying to answer this question. That's when the new term artificial intelligence replaced the machine intelligence, but essentially it's the same thing. And after the workshop, many programs were developed that were able to solve algebra problems, prove geometry theorems, and learn to speak simple English, right? So after seeing that, people got really excited and thought, well, AI is going to change the world now. And the first generation of AI researchers predicted some very strong predictions. So in '58, one of them said that in 10 years, computers will beat the world's chess champion, and also that they would discover and prove an important math theorem. So you probably know that computers can beat the world chess champion and the world Go champion, but that didn't happen until much later, right? So they also said in '65 that in 20 years they will be capable of doing anything a man can do. And well, we're not there yet, right? So they also said that in 1970 that in 3 to 8 years, machine with general intelligence of average human being would exist, right? And the funding agencies bought in all of those optimism, and they provided huge funding in between 63 and 70 from DARPA and similar agencies in the UK. Well, guess what happened? So the public expectations were way too high, and the promised results were not delivered. So the lesson here is really that one does not simply simulate human intelligence. That's more complicated than they thought, right? I didn't mention, but if you have any questions, feel free to interrupt me. We don't have to necessarily answer just 2 questions at the end. Okay, so then came the first AI winter, and even the most impressive programs could only handle trivial versions of the problems they were created to solve. And this was in part due to several limitations that we had at the time. Some of them were discovered during the winter, right, during the first winter. So one of the fundamental limitations had to do with computer power. Even the most powerful computer at the time could only process 10 times less data than the human retina. Right? They also discovered some theoretical limitations in specifically some problems that could have an exponential, like a combinatorial explosion in terms of how many solutions they would have, or they would have to be explored. And there wasn't an easy way out. So in practice, they found that the computers were not capable of common sense. They would try to add rules to describe how humans interact with the environment. And it was very difficult to get the computer to do certain things. Okay, so after this first delusion period, there was another boom in AI, and but it came with the development of expert systems. So instead of trying to instill common sense to these programs, they were focusing on knowledge, on specific knowledge that were able to accomplish certain tasks that are specific to a domain. So many companies across the globe, they developed their AI departments, and they were creating specific hardware, specific computers and software to solve their problems. They were also very specific. And that's where some funding returns to AI. Japan, for example, they launched this project called Fifth Computer Generation, where they're trying to use funds to develop programs capable of translating, interpreting pictures, and human-like reasoning. And also, like similar initiatives were followed by the UK and US companies and the government as well. Guess what happened? Well, second AI winter. You can see how these things comes in waves, right? So the expert systems they quickly realized they were too expensive to maintain. They required specialized hardware, so if you want to do upgrades, then you have to develop those in-house. At the same time, desktop computers by Apple and IBM were gaining power and speed. They were becoming cheaper. So it would make sense to try to tap into these general purpose computers rather than trying to develop their own. So Japan's goals, not surprisingly, had not been met. And this whole industry, which was worth $500 million, was demolished overnight, essentially. Okay, so a few years after that, when the expert systems were gone, the AI name got completely tarnished. So even though some researchers were still working on AI-related topics, they wouldn't call it AI, right? They didn't want to be associated with this term. So if you might remember this, but in 1997, IBM created a program called Deep Blue, which is shown here in this computer, which was finally able to beat the world chess champion, Garry Kasparov, at the time. So this is in part due to like a lot of engineering behind this, but mostly because the compute power has advanced so much that it was capable of processing 200 million moves per second. And that's what made it able to outperform the champion. So in a similar vein, lots of solutions for problems throughout the tech industry were developed. They were doing some sort of data mining, industrial robotics, speech recognition, and also in medical diagnosis. But they didn't want to call it AI. So during that time, a lot of these methods came under what is called nowadays as machine learning. So you can think of artificial intelligence as like a superset of all the techniques that enable machines to mimic human behavior. They're trying to do what humans do. But machine learning is really like a subset of these techniques that can learn without being explicitly programmed, right? So you essentially give a bunch of data, you have different features or attributes of the data, and use models to learn how to make predictions. So this became really popular until between 1993 and 2011. But after 2011, three factors have really come into play. First, we have seen like huge amounts of data that became publicly available. These are, or maybe just companies collecting data and just being able to use the data because they had now faster and cheaper computers, and also more advanced machine learning techniques. So these three factors together really kind of propelled AI, and they gave birth to a whole new area inside machine learning, which is called deep learning. Have you heard of deep learning before? Okay, so some of you have. Okay. So deep learning is still machine learning and it's still AI, but essentially it uses large neural networks, so very deep neural networks that can directly extract patterns from data. And the idea is that it can give raw data, it can give an image, it can give like voice, and you learn how to make predictions, how to generate diagnosis based on the raw data, rather than having humans to manually engineering which attribute should be important for this prediction. Okay. So nowadays, you may not realize, but lots of the applications, lots of the AI applications that you might use are they're based on deep learning. So if you use Siri, if you use Cortana on Microsoft or Google Assistant, they're all based on, we call it AI, but in practice, these are deep neural networks. Self-driving cars, ChatGPT, Stable Diffusion, which is the one I used to generate the image, and drug discovery for many pharmaceutical companies is powered by deep learning. Okay? So when people say AI, most of the times they mean deep learning. Okay, so we talked about the history of AI and how we came to this point. I will show you in a few slides what these AI models look like, okay, and how do they learn from data. So I mentioned the term neural networks, and these are not biological neural networks. So obviously they are artificial, but they are inspired by the biological ones, inspired by the brain. So you may have seen this. It is a biological neuron, and it has dendrites, which essentially are receptors from other neurons. There is a cell body, which aggregates signals coming from the dendrites, and there is the axon, which is a transmitter to other neurons, right? Transmits signals to other dendrites. Okay, so when we're looking at a scene, essentially the optic nerve captures signals, and the signals are transmitted until it reaches the dendrites of several neurons. And so you can think of these signals as the input, right? So these are electric impulses that are coming from other neurons. And these impulses are combined by the cell body. And finally, there is some sort of activation threshold here. So if the signal is above a certain threshold, then it fires an impulse that goes through the axon, and it travels to the other neurons. So this is the output. Okay? All right. Nothing new here if you remember the biology classes. So this is what an artificial neuron looks like. Very similar. We still have a bunch of inputs. We have something that combines those inputs and an output. Also similar to the neurons, they have, I'm representing these inputs with different thicknesses. So you can think of that as maybe if some of them will attenuate the signal a little bit, and some of them will amplify it. Right? You also have other inputs which will have negative signs. So you can think of that as inhibitors rather than stimulating. Then if we want to pass as input to my neuron, my artificial neuron, an image, we first have to convert that image to numerical values. So let's say that these are my numerical values. Then all that the artificial neuron does is really take each of these values and multiply by these weights. These are weights, and sum them. So you combine impulses, and then you get a number. And you compare that number with a certain threshold. So if the threshold, if the signal is above the threshold, then I'm going to say, well, it's a cat. And I output a number 1. 1 means a cat. Or I'll output a 0 if the signal is at most 0. Okay. So, but then you might be asking, all right, but how do we get these weights in the first place, right? Before I explain this to you, just a quick recap. Essentially, you can think of the input as a list of numbers. So these are the numbers that we saw there, and the output as a number or a label. And then we can write this operation up here as a matrix multiplication. And I'm only showing you this here because this is the reason why it's important to have graphics cards, powerful graphics cards to do deep learning because they are very fast at doing matrix multiplications. They can multiply huge matrices in very a very small amount of time. So everything in a neural network is essentially based on built on matrix multiplications. Obviously, distinguishing between cats and dogs is hard to do with a single neuron. And if one neuron is doing a mathematical operation, you can stack several of these neurons. You can combine them in some sort of layer that it will represent more complex functions. So here is, again, the same set of inputs. And now instead of having a single neuron, right, and connecting all the inputs there, I have a bunch of neurons. And then I can do some sort of nonlinear transformation and then have more and more layers. And that's how I get a deep neural network. OK. So this is the prediction. But how do we train all the weights that are associated with these edges, with these links that I'm drawing here? Essentially, first of all, you collect large amounts of data. Okay, where is this data coming from? The data can come from Wikipedia, from Twitter, which is now called X. It can come from Instagram. So you collect images, you collect text. And let's say that I want to train a network that distinguishes between blueberry muffins and chihuahuas. That's not a trivial problem. It's very hard. Anyway, so you take pictures, and then each of these pictures have a label. This one, I believe, is a blueberry muffin. Then you transform that into numerical values. This is a matrix of numbers. Then these are the numerical values here. And then initially, I don't know how to set the weights of the neural network. I'm going to set them at random. And that is going to give me some output that can be incorrect. Maybe it's saying, well, the probability that this is a chihuahua is 90%, which is obviously wrong. But then I'm going to use this measure of error. I'll compare that with the actual ground truth label. And then I'll update the weights of the neural network so that my next prediction is going to be 0.75. And I keep repeating this process with more and more images until I get to very reasonable errors. Okay? So now it's saying probability that this is a chihuahua is 1%. So that's roughly the idea of how we train neural networks. So going back to ChatGPT, that is a large language model, which is also a neural network. But the difference is that now it takes text as input, right? So each of these words is essentially fed into the large language model, and well, I guess I'm going to go over what is a large language model first. So that's a neural network that generates human-like text, and they're trained to generate sentences that are seen, like similar sentences to those that are seen in books, on the internet. So they use a lot of data from the internet and from textbooks to train a model like this. And for example, one of the large language models called Falcon 180B was trained with 3.5 trillion tokens. Tokens are like words or parts of words. That's a huge amount of text. They do need some sort of human-in-the-loop feedback to learn how to interact well with users, because users want to write a sentence and they want to get an answer that is related to the sentence. It sounds like a conversation, right? So when you type something, a question like this in ChatGPT, each of these tokens, each of these words are fed to the model. And it does some sort of computation. And it tries to output a sentence that should come after this one, right? It tries to output a sentence that should come after this one. And it generates one word at a time because the next word will depend on the previous ones. There is no guarantee that these answers are correct. It essentially it's trying to generate a sentence that is very likely. It's likely in the sense of natural languages. But you would be surprised as to how many times it's just BS, right? It's, beg your pardon. Okay. So, other than ChatGPT, there are many examples. I can give you, like, just in a day-to-day basis, AI is in many places where we don't realize. For example, if I wake up and check how long it's going to take for me to get to work using Google Maps, then they're using a neural network to essentially estimate how long it takes each segment on my way. And they actually check many different paths. If you have one of those Nest thermostats, then once you leave home, you realize, well, you're not home, and then it turns off. It essentially does something. Also very popular, these robot vacuums. They go around and they have a map. Sometimes they have a map of the house, or sometimes they have just kind of collision detection. They go around obstacles and things like that. Then when I'm going back home, I can call my wife from the car using Siri. She says, well, I have to stop at Trader Joe's to get dumplings because we don't have food. And then, like, I never go to Trader Joe's. I rarely go. And then sometimes you go there and the credit card gets blocked. There's no human behind each of these transactions, analyzing each of these transactions and say, Fabricio never goes to Trader Joe's, right? Everything is automatic based on, like, this is AI powered, right? So it looks at your history and tries to guess if this is part of your typical behavior or not, okay? And obviously, at the end of the day, I like to watch Netflix, and you get recommendations of, well, things you should like, right? Okay. Some examples of how AI is being used in the workplace. When you're reading and answering emails, you don't like to get spam. Then there is the email filter is intelligent. You don't have to specify each rule, right? And it sends things automatically to inbox and spam. Sometimes it makes mistakes, and then you're waiting for something that never comes. Also, when you're typing, then you have autocomplete, you have autocorrect. And if you're, sometimes I don't know how to say certain things in English, and then I could use ChatGPT or Google Translate to improve the text. So other examples, a graphic designer, I mentioned that before. I have a friend who lives in Toronto, and essentially he always starts from a prompt and gets an image that might look like this, and then he has to edit different pixels, different regions to look exactly like the image that they wanted. A programmer can sketch code using ChatGPT or Copilot. This is very common nowadays. Even like people who program really well at a very sophisticated level, they still use Copilot to get started. And musicians can correct imperfections in their songs, the things that they're recording. Some people might argue that this is not great because these imperfections is what they make them real. But anyway. Also in education, since November 2022, this has become a big concern, right? It's very good at generating essays, although they have this weird feeling they don't seem authentic. But they're not very good at math. If you try to input math questions, you have to count things, it doesn't do a good job. Because as I said, it's just trying to generate a sentence that looks real. I have a colleague at WPI that essentially he leads this platform called Assistments, and this platform and other similar platforms can derive instructional insights based on data collected from students, can provide customized tutoring, and even assess the effectiveness of different strategies in class, right? So these are, I guess, a more positive view of things you can do in education using AI. Other things that are currently happening, robotic surgery, better medical diagnosis. So these are all things that benefit from AI. This is one example where, from a paper in 2021, where they're trying to detect COVID from chest X-ray images, right? And then the model, in addition to telling you whether the person has COVID or not, would indicate like why the model thinks this is the case, right? Here is a really cool example where drug discovery is accelerated by AI models. And this is an example of a potential drug molecule. This is from a paper in 2020 that became a highly prestigious journal, and it became very cited. So the idea is you're going to take a molecule, existing molecules, and for which many properties are well known. And you train an AI model to read from that input and try to predict or estimate these properties. And once, if you have enough data, then the model learns how to represent molecules and make predictions about their properties, including what's their effectiveness against certain diseases. So then you can take a bunch of new candidate molecules which have never been synthesized, and then you can rank based on the predicted effectiveness. Is this going to be effective against that disease? Is that going to be toxic for human use? And that allows them to essentially narrow down a bunch of molecules to a much more reasonable set, and have the biomedical experts train, do some additional screening on this process, run clinical trials, and then discover new drugs much faster, essentially. Okay, so in terms of ethical considerations, there are all these questions regarding accountability. If a self-driving car is involved in an accident, who is the culprit? Is it the programmer? Is it the company? Is it the person behind the wheel? You may have seen like a lot of discussion in newspapers about this. Another problem is copyright and privacy issues. So I told you that the image that I generated is completely new. But because it's trained on existing images, can it really be considered original? Is this a copyright infringement violation? And this is something that a lot of people are concerned about. How can you determine if the AI was trained with your data? Right? How can I ask, how can I ask ChatGPT if any of the things that I wrote, any of the papers that I wrote are being used there, and can I force them to forget about anything that is coming from me? Also, other ethical considerations that come into play are transparency. If they're using models to determine who gets a loan, can you find out, right, what exactly makes your loan get denied? And a big concern, it has to do with the bias in these models. So in many cases, the AI predictions can be harming minoritized populations for a variety of reasons, but mostly because they are trained on data that is generated by humans. So if that data is biased, the models will be biased as well. They will generate biased predictions, and they might, for example, recommend certain additional testing for certain people that go to the doctor, but not to other people that might have the same probability of having the disease. Okay. So I'm going to. These are the videos that I was trying testing in the beginning, and in terms of future trends, I expect to see a lot of AI video, not just people not using AI to generate images, but also to generate video. I'm not a fan of Kanye West, but anyway, there is a trailer of a new clip that all the scenes are generated using AI. Lots of, I guess, opportunities in regarding medical LLMs. So these are large language models. So you have ChatGPT that is specifically for asking for health advice. And this has a huge benefit of reducing waiting times for doctors. Everyone knows that it's very difficult nowadays to get an appointment, especially if you need something very specific. Digital avatars, and I'll show you a video. I think AI video is very promising, and we're going to see a lot of things coming in there. Also, digital avatars might completely reshape the way we work remotely. And this is one example. I don't know if you follow Lex Friedman's podcast. So this was him interviewing Mark Zuckerberg using Meta avatar technologies. So this is in the metaverse, and they created digital avatars, which essentially recreate the facial expressions without actually using video. They infer what are the facial expressions. They even exaggerate a little bit. So let me try to show you very quickly this one. All right, so we're coming to the end, and I'll take questions. Key takeaways: AI is not a new thing. It has been around for since the 50s, and it has seen many ups and downs. And maybe we're seeing an up, and a lot of people are optimistic about what we'll be able to do. Maybe we'll come to like a more skeptical view in a few years. So I guess we know that what people call AI nowadays are mostly neural networks, and we know that the artificial neurons, they take a numerical input, they do some sort of computation using matrix operations, and we can train these neural networks by adjusting their weights so that the predictions match the data. That's why it's important to collect data. And obviously AI is everywhere. We may not realize. There are many ethical considerations that are being discussed, but it's definitely underway, right? It's already reshaping workplace, education, and healthcare.